Oh, hey, Murray students. Today, what we're going to do is we're going to go over the metric measurement notes. We are going to actually do some practicing, actually measuring things, paper, pencil, and then I'm also going to give you some interactives that you can do digitally this week. All right, so hopefully by now you know how to take the notes, the guided notes, which is they're in the shoe. So you want to take that PDF, bring it up to Notability, and have your screen split so that you can listen to this and then fill out the guided notes as we do it. Okay, so if you haven't learned how to split your screen, there is a video on how to do it. So watch that first. So you can have your screen split, you can have your guided notes from the chew, and then listen to this, which is in the chunk. All right, it's pretty long. I'll try to do it as quick as I can. So there are three things we are going to talk about. We're going to practice measuring length, right? We're going to practice measuring volume, and we're going to practice measuring mass, those three things. So length, volume, and mass. So we're going to start with length because it's probably what you're most used to doing. So length is the distance between 2 points. So in your guided worksheet, if you could please write distance in the first blank. So length measures the distance between 2 points. So here on the map, 2 points, Minneapolis and St. Paul. That's the distance between. If you have a pencil, it's from the end of the eraser to the very tip of the lead. Okay, from one end of the box to the next. Now we're going to use metric because the metric system is what we use in science. There are ancient instruments, right, where our system came from with like feet, right, a hand span, an arm length. Well, that wasn't so great because some people had different size feet, different arm length, so it wasn't so accurate. So we are going to be using the metric system. Okay, so one thing that we use in the classroom is we are going to use meter sticks and we use rulers. Okay, so we're going to practice. So the guitar is a meter long. So here, the basic unit of measurement for length is a meter. So in your guided notes, if you could put M, because that's how we abbreviate meter, put M in your notes, and then here, so what a meter equals. Well, if you want to think about it in terms of what you're used to, a meter is like about a yard, okay? And there are 100 centimeters in every meter. So a centimeter is like the thickness of your thumb. And there are 1,000 millimeters in a meter because millimeters are very tiny, like the blade of a grass. So if you could put this in your guided notes, 1 meter equals 100 centimeters equals 1,000 millimeters. And you can always pause this and fill it in as we go. Okay, now here's end of a meter stick. So the tool we're going to use is the metric ruler. So if you put that in your guided notes, metric, ruler, or a meter stick. So in the picture, we have a meter stick. And see how this is 90? The very end is 100 because there's 100 centimeters in a meter. Each number represents a centimeter. So this is 90, 91, 92, 93 centimeters, right? And remember, centimeters like the thickness of your thumb, if you look at that, and the millimeters are the tiny lines. That's like the blade of grass. So there are 1,000 millimeters in a meter, because remember, millimeters are very small. All right, so we're going to practice using a ruler. Okay, so in your guided notes, if you can see, these are underlined, right? So here's 1 centimeter. So 1 millimeter equals, this is important, it's because it's on the decimal, is 0.1 centimeters. 1 millimeter is the same as 0.1 centimeters. So right here, this is 1 centimeter, right? Right here is 0.1 centimeters, okay? Because there's 10 millimeters in 1 centimeter. Okay, when you are doing this, you have to be really careful. So you line up the object on a ruler. I bet you've used rulers before. So the one end is at the 0, and then you line it up. Now, each one of these numbers is a centimeter. So if we're trying to measure this, right, we would count 1, 2, 3, 4, 5, right? And then each of these lines is 0.1. So this screw would be 5.1. Okay, so you find where the end of the object is and look right where it passed. Okay, if you didn't get that right, so right where it passed. So then this is the whole centimeter, and then this is the tenth. So 5.1 would be our answer. Okay, and the metric length is always a decimal. So if you could write decimal in your guided notes, do that right now. It is not a fraction. Okay, so the metric length is always based on a decimal. Okay, so let's practice. So remember, these numbers are centimeters. 1, 2, 3. Okay, so it's 3 centimeters, and then there's 2 lines after that. And so this each one is 0.1. So if there's 2 lines, it'd be 3.1.2. I bet you got that right. Yay. All right. A little practice now. Okay. So the centimeters 1, 2, 3, 4. And then we count up how many lines past that. 1, 2, 3. Remember, those are each 0.1. So it'd be 4 point, count 1, 2, 3. So 4.3. All right. Yay. All right, now on to volume. Volume is how much space that matter takes up. So all matter takes up space. I think you know this middle one from math, where if you want to find the volume of a cube, right, you can do length times width times height. So anything that has a regular shape, you can just measure the length, the width, and the height, and that gives you the volume. What we're going to do is we're going to practice measuring graduated cylinders. So these right here are graduated cylinders. And so we're going to practice using a graduated cylinder this week. Okay, so here, a liter, please write this in your guided notes. Liters, and how we abbreviate that is a capital L. So liters, capital L. So when we write milliliters, we write a lowercase m and then an uppercase L. So milliliter, right? So 1 liter has 1,000 milliliters. Remember, the milli means small. So millimeter, milliliter, those are very small units. Okay, the tool we're going to use is a graduated cylinder. And yes, what's so funny in the middle is that it's very smart, graduated. It's actually graduated because it has so many lines of measurement, so it's quite accurate. So that's why we like to use the graduated cylinder. So there's different sizes depending on what you measure, how much liquid you are actually measuring. So if you could write cylinder in your guided notes. All right, now this is the important part, is that when you put a liquid in the graduated cylinder, you get this curve shape, this bowl shape right here. And we call this a meniscus. So we have to learn how to read the liquid in a graduated cylinder by this meniscus. So if you could write meniscus in your guided notes, meniscus. Okay, so you always read it from the bottom. You always read your graduated cylinders at eye level. You would always put it on a flat surface and then get down and look at it from eye level, and you read it from the bottom of the meniscus. So if you can write eye level in your guided notes. Okay, so let's do some practice. Now here we've got from 30 to 40, so we always have to check. And then we count up 1, 2, 3, 4, 5. And remember, each one of these is going to be 0.1, right? So each one is going to be 1. That's silly of me, because we're going from 30 to 40. So it would be 35 milliliters. Okay, now this is the tricky one. So we look at the bottom of the meniscus. So right here where that purple arrow, this is the bottom of the meniscus. Now we have to look, because now this is just one whole number from 8 to 9. So here we have to get, it's not a milliliter for each line, it's going to be 0.1. So this is where it gets tricky. So always look at the measurement, the numbers. So this is just one whole number. So we're going to count up, that's 8.1, 8.2, 8.3, 8.4, 8.5, 8.6. The bottom of the meniscus, 8.7. All right. Now here, that's what we're going to practice, is that here, this was a little bit easier because we go from 30 to 35. So that was like the first one, where each line is worth 1 milliliter. So this would be 31, right? Because it's 31, 32, 33, 34, 35. Now, if we look over here, this is just going from 7 to 8, so just one whole number. And if you look, there's how many lines? 1, 2, 3, 4. So 7.2, 7.4, 7.6, 7.8, and then 8. So here, each line is 0.2. So sometimes these can be kind of tricky. So make sure that you're always looking at the number from 1 to the other and seeing how it's broken up. All right, mass. Mass is the amount of matter in an object. So everything is made of matter. So if you could write matter in your guided notes. Mass is the amount of matter. M&M is how I always remember it. M&M, mass and matter. All right, matter is everything. Yep, solids, liquids, gases. So if you could write that in your guided notes. Matter is everything. Everything is made up of matter. It's made up of stuff, everything. Okay, units, we're going to use grams, so little g. So write that in your guided notes. Gram, little g, kilogram, kg, milligram, mg. So 1 gram has 1,000 milligrams. 1 kilogram has 1,000 grams. So a gram is not that much. So if you think about a gram being like a paperclip, okay? So an apple is like 100 grams. A pineapple is like 1,000 grams. So grams are pretty small. Like if you were going to weigh yourself, you wouldn't weigh yourself in grams. You'd weigh yourself in kilograms. All right, this is the tool that we are going to use. It's called the triple beam balance. Because that's such a lot to write, we just abbreviate by TBB. So if you could write TBB, it can weigh up to 0.1 gram. So it can be pretty accurate. Okay, so the things you have to know, this is the pan. That's where you put the object. The riders are like the weights, because remember, it's a balancing a weight thing. So there's 3 riders, and each of those riders are on the beams. So there's 3 beams. That's why it's a triple beam balance. And then we have this pointer right here. You always, when you want to balance something out, this pointer has to be lined up with the 0. Okay, so you want to balance it out until the pointer is lined up with the 0. Okay, so first you get your triple beam balance out. You make sure that the pointer is at 0. You move all of the riders over to where the pan is, so all the way over to 0. And then you put your object on the pan. You start with the largest rider and work to the smallest. So the largest weight, and then you work to the smallest. Unless you know that you're weighing something that's tiny, like a paperclip, maybe you wouldn't start with the largest. But in this case, with the apple, we're going to start with the largest one. Okay? Move each rider until the pointer drops below 0, and then you move it back 1 notch, and then you go to the next rider. So this is a little confusing. So if you put this apple on here, right? You start with the heaviest one, which was this rider right here. So they moved it to 100. And it didn't drop. It didn't go to 0. They moved it to 200, and then it dropped. So then you move it back 1. And then you start with the next rider. So then you would start with the middle weight, which is right here. Okay. And then you would start to do the smallest. And when you get it all balanced out until it's the pointer is at 0, then you have the mass of the object. It is kind of confusing without practice. So that's why we are going to practice. Now, when you use all 3 of the riders, you have to add up the measurements of all 3. So we've got 300, 50, and 4. Those are the whole numbers. So 354, and then we count over. These lines are going to be 0.1. So we count over 1, 2, 3, 4, 5, 6. So let's add those all up. See, we've got 300 from the back, 50, and then 4.6. So that object on the triple beam balance is, the mass is 354.6 grams. And this will take some practice, but I know you'll all get it. All right, so that is it. Remember to, hopefully you came to the Google Meet so I could do this with you. If you're doing this on your own and you have any questions, remember that you can come to office hours Monday through Thursday from 2:30 to 3. Just pop in and ask me any questions. I'd be so happy to help you. All right. I hope to see you at the Google Meets. Okay. Bye.